Hello, and this time we're looking at sequences. And so just general chit chat about sequences first, just so you know what the different words are. Here we've got a sequence of numbers, and each number separated by a comma is called a term. And there's two ways you can define how a sequence is growing. Obviously, you need to know the first term of a sequence in order to where it starts, and then you can either grow it by a term-to-term rule, which tells you what you do to that term to turn it into that term, and then you do the same thing for that term into that one, and into the next one, and the next one. And the other way is that instead of going from one term to the next, you say, okay, well, this is the first term, the second term, the third term. Is there a way to go from that number of position, so the fact that I'm the third term, and go from that number 3 to that number 9, the number 4 for the fourth term, and turn that number into 12? And so we have these two different ways of doing it, from one to the next, and from where you are to the value. The second one is far better, because if you imagine I wanted the 100th term of this sequence, if I'm going term to term to term to term, I'm going to have to count through and write all of them down until 100. Whereas if I have a rule that goes from where I am, the 100th term over here, straight, change that number 100 into the value of the sequence, then it's much quicker, much more powerful. But anyway, let's work through some of these examples and just make sure we've got the basics down for these kind of sequences. So in exams, you can often be asked to do all of these things. The first one being continue each of these sequences for 2 more terms. So you just got to work out what's happening each time. Now you might say, double 3, you get 6, but you need to just check that it still works. Double 6, you don't get 9. No, it's just adding 3, add 3, add 3, add 3. So just check that it's whatever you're choosing, it is doing it multiple times. Just to make sure you've got the right one, and not thought of something else which works for the first bit, but not for everything. So plus 3, so you just write down the next value, comma, write down the next value. This one could be plus 9, but that doesn't work. It's actually times 10, times 10, times 10, times 10. So just keep doing the same thing. We're going to get 100,000, and then we're going to get 1,000,000 or 1,000,000. It doesn't matter if there's decimals. It's just you just got to look for the pattern, a way of mathsing from this term to this one, and then check that it works for the others. And hopefully you can see this is just adding on a half. So it's going to be 3.5 and 4. You could write that as 3 and a half. I suppose we should keep the formatting. And this one here, we've got decimals, and it's going down each time, so we're losing 0.2. So it's going to go to 1. And then to 0.8 as we lose another 0.2 each time. This question, it's a bit more formal. It wants us to write down what the term-to-term rule is and then fill in the missing numbers. So for the term-to-term rule, we'll ignore that bit for now. We'll look at this step and see if it is the same here. So I'm looking at this thinking, you add 5 to that, you're going to get 19. And then if I add 5 to this, I do get 24, so it's blatantly going to be, the rule is plus 5. And you can just write it down like that, even at a GCSE exam, well, certainly for an Excel, then it's acceptable to say that what we're doing each time, the term-to-term rule, we're adding 5. And so now we can work this one out. 4 add 5 gives us 9. And that seems to fit, 4, 9, 4, 9, 4. Seems to be sensible as to what's going on. Same thing in part B, it's going down by 3 each time, even though they're negative. Not even though they're negative, they are negative. And from -1 to -4 is reducing by 3, so it's a -3 situation. So we've got to work backwards. We've got to think, okay, well, what would this be if I reduced by 3 and got this? Or, to do it backwards, if I add 3 to that, and then I add 3 to that, and we get the sequence. Most people find the term-to-term rule not too bad. You just got to look for a link between two numbers and see if it exists in the other numbers as well. The last one, people struggle with this position-to-term rule idea, and you've got to remember that the value of n is where you are in the sequence. So for the first term, n is 1. For the 7th term, n is 7. For the 1296th term, n is 1296. Okay, it's just the value of n is just where are you? And for the first 5 terms, I'm going to have n as 1, 2, 3, 4, and 5. And then this way of writing it, a lot of times you don't see it like this. You don't have the tn bit. You just have the position to term rule or the nth term rule written just like this without that equals. But if you do have it, it's just saying the term, yes, the t is the sort of the term in the sequence, and then this number is saying which one. So term 1 is 1 plus 10. Well, I can work that out. Term 2, yes, for n equals 2, is 2 plus 10, which is 12. Term 3 is 3 plus, yes, and so it carries on, and we get our sequence for the first one, just like that. Same thing here. Term 1 is 1 take 5, minus 4. 2 take 5, minus 3. I think I might have said minus 4 there. N take 5, so 2 take 5, 3 take 5, 4 take 5, and 5 take 5. So, just like that. The good thing about this is we don't have to go in order. It would be better, in a way, if it said generate the first term, the 5th term, and like the 100th term, just to prove the point. If you want the 100th term here, you don't have to count it through. Just say the 100th term is 100, take away 5. It's just 95. We know that straight away because we're moving from where we are, the n value, straight to that sequence value. And these more complicated ones, we still just substitute it in. If you want the first term, it's 2 times 1 plus 1. The second term, 2 times 2 plus 1. 3 times 2 plus 1. And so on and so forth. And here again, it's 5 times 1, because that's the value of n for the first term. 5 times 1, take 2. 5 times 2, take 2. 5 times 3, take 2. 5 times 4, take 2. Hopefully I've not made any mistakes there, but I'm sure you'll let me know in the comments if I have. So hopefully you can see that for term-to-term rules, you're looking for this, this link between pairs of terms, and you can do funny things like working out things backwards. If you know the rule here, you can just undo it to go backwards. But the position-to-term rule is actually much more helpful because it tells you, if someone asked you for, what's the 73rd number in the sequence, you wouldn't have to count it all through. You'd just say, well, what's 73 plus 10? Well, the value will be 83 then. Okay. Hopefully that's crystal clear, but invariably there'll be some who still have a bit of issue with that, so let me know in the comments, and ta-ra for now.